This is my third video that is based on identity, that is x plus y plus z. If it is 0, then x³ plus y³ plus z³ is equal to 3xyz. Actually, this is the extension of the eighth identity according to textbook. So what do we know that if x plus y plus z is equal to 0, then its sum of their cube x³ plus y³ plus z³ should be equal to 0. So I have taken 4 questions over here that is based on this. Let's start with the first one. In the first part, we have to factorize this. Now, as we know, this is the sum of cube of 3 terms. So we should first try finding out is the sum of the cube of these 3 terms are 0. That means say if I take the first term, say x is equal to a square minus b square, say y is equal to b square minus c square, and say assume z here, consider z as c square minus a square. Now figure out that what you are getting on adding x plus y plus z. Clearly, on adding this is a square minus b square, y being replaced with y square minus c square, b square minus c square. And if you plug in z as c square minus a square, you'll find that a square minus a square get cancelled. So is b and c square. So what do we get here? That we got x plus y plus z we got as 0. It implies that we can write x³ plus y³ plus z³ should be equal to 3x, y, z. Now, what was x here? X clearly was a square minus b square. And we have to write its cube. And y, which is b square minus c square whole cube. And z, which is c square minus a square cube. So this can be written as 3 times. This can be written as 3 times xyz. That means 3 times a square minus b square minus c square, and c square minus a square. But you have to keep in mind that this is a question of factorization, so we must write them in the reduced form. So I can further write a square minus b square, right? I'm going to factorize it further. I can write a square minus b square as a plus b into a minus b. And same way I can write b square minus c square as b minus c into b plus c. And finally c square as c minus a into c plus a. So this is the factorized form of this question. So whenever you find the cube of sum of 3 terms, figure out is the sum of these 3 terms is 0. In that case, we apply this identity. Now coming to the next question, it says a plus b plus c is 0. Then we have to find the value of this. So we already know that since a plus b plus c is 0, since a plus b plus c is equal to 0, it implies that a cube plus b cube plus c cube should be 3 times ABC. 3 times ABC. Now, if I see the question, what we have to find the value? We have to find the value of a square over bc plus b square over ca plus c square over ab. Now, what we can do here, first we will be taking the LCM here. Clearly, the LCM is a in ABC, right? Now, dividing ABC with BC, what we are getting? We are getting a, and a multiplied by a square is a cube. Same way, dividing ABC by CA, what we are getting? B, and B multiplied by B square is B cube. So is ABC divided by AB is C, and C multiplied by C square is C cube. Now, what you can see that here we have a cube plus b cube plus c cube, right? A cube plus b cube plus c cube. I can replace this with equation 1 here. As you can see, this is equal to 3abc. So if I replace this value with 3abc, this one from the first equation, and that divided by abc. So we see that ABC and ABC is get cancelled. So 3 is the answer for this part. Now, when I look into the third part, you see that it's almost the same thing. We have to show that this time. In the previous part, we had to find the value of this, and this time we have to show that this a square over bc plus b square over ac plus c square over ab is equal to 3. So we actually have done the third part as well. Now let's find out what to do in the fourth part. In the fourth part, we have the value of, so this is actually not based on this identity, this is based on different identities. So we'll be doing this in the another video which involves the identity a cube minus b cube.